Copernican philosophy. What you must be knowing what Copernicus did, right? The ancient philosopher Copernicus. Before Copernicus, everybody thought that, well, Earth is the center of the universe. Everything is revolving around the Earth. Because we are living in Earth, okay, we are very much biased that, well, Earth is the champion of the whole universe. And that God is so much kind to make this Earth such a peculiar world, and the whole universe is inferior to the Earth, and everyone is revolving around Earth. Earth is the center of the universe. But then the Copernicus came, and he disproved everything, and that was like a big, turning point in the history of science. That what Copernicus said is that Earth is not the center. The center of our planet system is Sun. That we are just merely one of the planet, 9 planets those days, right? That we are simply revolving around the Sun. That was such a drastic change of concept of the history of science. What the Copernicus have said that in his days, right? And something like the Copernicanism, the Darwinism, before the Darwin, human beings were, the champions of the whole life on Earth, right? The entire life, we are actually like the topmost in the ladder. The evolution is considered to be a ladder. Even the Lama considered evolution as a straight line ladder. But human beings are the top of it. Okay? And we are the ones who are immediate descendants of the God. That was the prevailing thought there, right? But according to Darwin, we are nothing. We are just a part of the nature. That there is no superiority associated with human beings, and that is a very big dramatic change in the 19th century philosophers as well as science. And of course the associated fact that what Darwin promulgated is that we are descended from apes, right? Our great grandfathers were monkey. So that kind of concept was very revolutionary in that days. Okay, so that is yet another big change that what Darwin has been doing those days. Is that clear? Now, well, Darwin always thought about the variations, right? Last class we were saying what the variations are, and how these variations affect on individual survival, on reproductive survival in apocalypse, right? And that is why the variations are of paramount importance in the world, right? In the evolution by means of natural selection, right? So selection happens on the variation, or the variation gives rise to various different individuals with differing capacity for the reproductive survival. Okay, so it is something like a playground for the evolution to happen. So without variation, of course, no evolution can happen, right? So what makes this variation? That is a very big concept here, right? So, well, Darwin was clueless, of course, right? So, now we know that this is all about the genes, right? That makes it mutations. Yeah, you told mutations. So mutations makes it a lot of variation. But those days, scientists were unaware about the process of mutation or everything about genetics, right? Though works of Becker-Menzel, he was a contemporary of Charles Darwin, but neither of them do not know each other's work. Okay, so that was a problem. So there is a quotation from the Darwin's book. Okay, so he was in his autobiography. Okay? So what he said is that, why did child often reverts in certain characters to its grandfather or grandmother or much more remote ancestor? Why a peculiarity is often transmitted from one sex to both sexes or to one sex alone, more commonly but not exclusively to the like sex. So he did observe a lot of things, right, in human beings. Yeah, of course, this is in context of human being. So sometimes you might have seen that in your family, some characters that your great grandfather had or grandmother had, that right now you are having it, or some of your peers is having that kind of character. That exactly that is what the Darwin observed. Okay, so again, certain characters are transmitted from mother to daughter and father to son. Most often, this is what the sex-linked inheritance, of course, that we know now. But these kind of things, the Darwin is thinking about it. He is contemplating what would be the mechanisms for this kind of transfer. So, prevailing thought, last class I said, the prevailing thought during the Darwin's time is what blending inheritance, right? Like a paint bottles, you are mixing these two paint bottles to get a new color, and then subsequently any variation rising them may be diluted. Okay, so what Darwin said is about gin and tonic. Okay, so cocktail mixing, right? If you mix this tonic to the gin for many generations, for example 100 generations, then there is no taste of gin there, it's only tonic water. And so that is what the blending. But Darwin never opposed this blending inheritance, because that was a prevailing scientific thought, well accepted scientific thought. But Darwin was not courageous enough to disprove that blending is not the right way, that it is something else, right? It's not just blending works here, right? Then there is this guy called Fleming Jenkins. Okay, so he was a Scottish engineer. Okay, so his name is Fleming Jenkins. What this person did is that he had sent his 5th edition of this book, Original Species, the Darwin have sent for an independent review. Okay, of course, the review is very important for any of the scientific publications, right? Even your papers, you have to send for reviewers. If you submit to a journal, the journal will forward your paper to reviewers, right? That is what you call peer review process. So during those days, the peer review, so natural selection by means of, original species by means of natural selection, that is a Darwin's book, right? So the person who got this book to review is this engineer, okay, this Fleming Jenkins. So then he published a review of that book in a journal called Northern British Review, okay? So in which he absolutely criticized that Darwin's theory of evolution do not work at all, in the assumption of the mixing of the characters. Okay, so that is something called swamping error. Okay, that is a term that he referred, and it is still very famous. Okay, swamping error. So you can actually have a look in the Wikipedia article or any of these articles on swamping criticism of Darwin. Okay, so it won't work in the assumption of blending inheritance. That was his criticism. To prove that one, he supposed a sexual pair, okay, male and female, had 100 offspring. Okay, so out of which only one offspring survived. Okay, then in subsequent, he was speaking about subsequent generations of this one particular offspring, which is having certain, now we call mutation, but during his time he said it's a kind of a sport. Okay? So this sport, there is this variant offspring of this 100 offsprings, is the only offspring that could able to survive and achieve the reproductive age, and then in his subsequent generations, so that sport, that character is diluting. Is that clear? So whatever the character it be, for example skin color, gradually it is being diluted from first generation, second generation, third generation. Okay, so after many hundred generations, so that character is subsequently too much diluted to an extent that population is getting rid of it. Okay? So in that way, it is next to impossible that any kind of these variations can result in survival of the fittest, okay, or evolution of these variations. That could never happen. So Fleming, of course, he was a mathematician as well as an engineer. So he did some mathematical calculations on Darwinian principles. So he modeled the Darwinian evolution, and he concluded that it is absolutely erroneous. Okay, so that was his criticism. So then again he did another very interesting, though racial, highly racial example, that in a shipwreck, white man arrives in an island of all black men. Okay, then he said he would kill many blacks in the struggle for existence. The white men will kill many black men in that black island for existence. Okay. Then God. Can anyone believe that the whole island will gradually acquire white or even yellow population? Eventually. It's next to impossible, right? The whole island is full of black. So how could the entire island be converted to white? In an assumption that the white is superior. So that is why it's racial, right? White is, of course, it's not superior. So in an assumption that the white is a superior characteristic, that it renders some fitness of those white population to survival. Still, even then, the entire island turning to a white is next to impossible in a blending form of inheritance. Okay? So that is his criticism, the Fleming's criticism. Right? Then this guy called Arthur Sladen Davis. Okay, so he is a grammar school mathematics teacher in Leeds. So he did a letter to Nature. Okay, Nature in 1871. Then he refuted the Jenkins calculation. His calculation, the original calculation of Jenkins, he said that out of 100 offspring, only one offspring survived. So if only one offspring survived, how could he find his mate, his or her mate? So it's next to impossible, right? So at least there should be two individuals have to survive, and it has to be male and female. Otherwise, the population is shrinking to an extent that ultimately the population is extinct. Okay, so that is why we pointed out this mistake in Jenkins' paper. Then we did another calculation of these two individuals, surviving these two individuals, and then what we found is that it will never get lost. Whatever the variations in a population, even under the blending form of inheritance, variations will never get rid of in a population. So it will survive in a population. So to exemplify what he did is that he was saying about cats. Okay, so a population of white cats, where a black cat is introduced in. Okay? Then of course he makes it. Then slowly the next generation will be a little bit of grey cats, right? Then after many generations, even after 100 generations, the dark hue will always remain in the population. So it will never disappear. That white cats will never come back again in that population, even after many hundred generations. Okay, so that is what it is. So the variations. Okay, so the variations, it persist. Right, this kind of sport, you can say, or variance can never get rid of. Right, so that was his Sladen Davis criticism. But still, Fleming's criticism is intact. Right, it is still valid. That that's a big mistake what Darwin have done in his theory of evolution. But in within the concept of blending evolution, right? So in that concept, you can never justify the Darwin's theory of natural selection. Okay. So of course, then particulate inheritance was discovered by Gregor Mendel, right? In his famous work on pea, garden pea, what he did, I'm not illustrating exactly what his experiments were, but it's very simple. All the textbook in biology is saying about his work on the green pea versus yellow pea. The first generation, what he observed is all yellow. Then the second generation comes 1:3, right? So those kind of breeding, that is cross breeding experiment on the garden pea, he could able to prove that it is what is being inherited is not blended on, right? It is particulate. It's like a particle or atomic. That is what the Gregor Mendel used in his treatise. Okay? Atomic. It's not blended on. Okay? So that is what in blending heredity as well as Mendelian heredity. The main difference here is that in the Mendelian heredity it is preserved, right? The chromosomes or genes are preserved in first generation to second to third and fourth. But in blending heredity it's mixed up. So whatever the variation comes in, a fit a variation that confers the population to be adaptive. Okay, so adaptive variation, even though an adaptive variation arises in a population, that will eventually get lost in blending inheritance, but that survives in Mendelian. Is it clear? So that is not actually mixed up. Okay. For example, a white, in a white population, a black, organism enters the group. Okay. Or the white population, one individual is having a mutation of black, and the black color gives that individual some advantage for surviving in that population. Okay, so there is an advantageous mutation, black color, of a population full of white. Let it be human being. For example, for the sake of simplicity, you are saying that an island full of white people, but one individual is turned out to be black. Okay, so that is just a mutation, right? So that after that mutation, the next generation, and this dark color, skin dark color, is giving certain advantage for the population. That is why the dark color have arisen, okay, for survival benefit. For example, an attacker, or let's say that dark color is giving some protection against skin cancer. Melanin in the skin is giving certain protection against skin cancer. Okay? So that black individual survives there, and of course he mates with a white individual, and then the second generation will be grey. Then the third generation, according to blending inheritance, it will be little bit lesser grey, right? And then the fourth generation will be much lower grey. But then grey color always survives there. But in that advantageous mutation is not preserved in that particular population, right? But in the case of Mendelian inheritance fashion, of course the first generation will be grey, right? If there is no dominant characters, if black and white are both recessive, none of these characters are dominant, then first generation is going to be a mixture, grey. That is what happens in human beings also, right? In interracial, mating. For example, if in US you can say, right, white men marrying a black woman, Negro woman, and then the first generation is going to be kind of a grey, right, grey kind, or yellow you can say. Then this individual mating with another grey individual, for example, or a yellow individual, then the next generation, is it going to be kind of a little bit more greyish or more yellowish? No, that is not the case, right? Next generation is going to be reverting back to their ancestors. So it's going to be black and white, right? That is a very interesting phenomenon that you can see that in human beings also. So that is because of the particular inheritance. Okay, so that is why to say that Darwin's selection works, inheritance needs to be particulate or atomic. Is that clear? Otherwise the good variants are eventually lost from a population. So those good individuals, individuals giving certain advantage for the survival of the population, needs to be survived, and to survive it you need to have a pattern of inheritance that actually contribute to the survival of that particular variation. Is that clear? So then the Darwin, he did acknowledge that he is not good in mathematics, and algebra had always been a problem for him in his school days, right? And even if he pursued mathematics, he could have never gotten good grades in mathematics. So that he did affirm that in his autobiography that is published long back. And then this Jenkins, whatever the criticism that this Jenkins put forward, was totally based on mathematics with lots of equations that made Darwin quite scared of this criticism. And finally what Darwin did is that he totally accepted that criticism, and he did say that he was flawed. Okay, so then on the 5th edition of the his book, he did incorporate some changes because of this flaw. Okay, but that is not actually his mistake, right? So he added this paragraph, or let me read that paragraph, right? This is a new addition to the 5th edition of that his book on the origin, right? I saw that the preservation in a state of nature of an occasional deviation of structure such as monstrosity, okay? Deviation, for example, an individual, one of you are turning to be a monster, okay? So everybody is just normal one. One of you are turning to be a monster, okay? Is of course a very rare event that if preserved, it will generally be lost by subsequent intercrossing with ordinary individuals, right? Nevertheless, until reading an able and valuable article in the North British Review, that is by the Fleming's Review, I did not appreciate how rarely single variations, whether slight or strongly marked, could be perpetuated. So it's not a variation perpetuating. See, he changed that variation to variations, okay, plural form. So just one variation will be eventually lost, but you need to have number of variation from number of individuals in a population for that particular variation to survive in a population. Is that clear? So just merely one variation cannot be able to change the entire population to another one, but you need to have variations in various individuals, right? So that is what he saw. So then what he did is that he changed all forms of individual variation. Wherever the occurrence of this kind of terms in his book, he changed everything to individual variations. Not just one variation can able to change it, okay? Or any variation, he changed that to any variations. So these are all actually an effect of Fleming's criticism. Okay? But Fleming's criticism is indeed not really valid, because now we know that the mechanism of inheritance is through particulate form, right? It is not blending. So, but to put his book in a constraint of blending inheritance, he needs to do this kind of changes. Otherwise, it's next to impossible, right? The people will not accept his theory, because as per that blending form of inheritance, that his theory of evolution will not work. Is that clear? Okay. So that is what. Okay. Now after Darwin, what are the new developments in this field? Right. So there is something called neo-Lamarckism. That's a very important thing, right? It's not neo-Darwinism is something else. It's neo-Lamarckism. What Lamarck said is, well, so many lot of contributions that Lamarck have done, except especially adaptation, significance of adaptation in the process of evolution. That is Lamarck's first contribution and most important contribution, right? But he also said that inheritance of acquired characters occurred during an individual's lifetime, and especially due to interaction with the environment. So environment can change certain character, implement certain characters in an individual that can able to pass on to the subsequent generations. So inheritance of acquired characters, right? So that is what he said. So that particular, what is that theory you can say, or hypothesis of Lamarck is still being followed by many, evolutionary biologists. Okay. So in one of this one, one historian, Peter J. Bowler, okay. So what he said is that one of the most emotionally compelling arguments used by neo-Lamarckisms of late 19th century was the claim that the Darwinism was a mechanistic theory, okay, which reduced living things to puppets driven by heredity. So we are helpless individuals. Okay? Even if you have a very interesting variation that can able to, of course, if some of you are having a deleterious variation, you are quickly removed out of the population. There is no way that people having a bad mutation can able to survive. Right? So that means that we are nothing, we are just puppets. We are simply playing in the field of heredity, that we are helpless. Okay? But according to Lamarckism, that gives certain hope that even if you are not suitable to the environment, you can simply go to another environment. So you can survive in that environment. Okay, if for example, if the black color is not selectively advantageous in a cold environment, right? So black guys can simply migrate to a hotter environment and they can survive in there. Right? That is a very interesting feature of the Lamarckism that many of these modern evolution biologists appreciate. That this gives certain hope, and everybody is after hope, right? We need certain hope as well. So that is what, right? Lamarckism, in contrast, allows individuals to choose a new habit when faced with an environmental challenge and shape the whole future course of the universe. You can change the whole future course of the universe by choosing a different environment. Okay, so that is what they did. And then August Weismann, the famous. Can you say where this Weismann is from?
Germany.
Yes?
Germany.
Germany. Where this person is from? Anyone? He is from Israel. Okay, and the Israel is renowned for this August Weismann, that Israel's top scientific lab, scientific institution is named after him. It's called Weizmann Institute of Sciences. Okay, so there are several Nobel Prize winners from that institute. It is one of the top institutes of scientific research in the world. The Weizmann Institute of Sciences. So this guy, what he did is that he cut the tails of rats. Okay, so to say that the next generation of rats will not inherit the tail, rat tail. To disprove Lamarckism, right? In certain degree, he could be able to disprove that this Lamarckism is entirely flawed, right? But very interestingly, these days, if you read the literature, Lamarckism is coming back, okay, with much more force. And there are several high impact factor journals are publishing papers that are in claim for Lamarckism. Okay, so I have linked certain papers there. Okay, so it's not by a DNA sequence. So normally DNA sequence equates classical genetics, right? The Mendelian inheritance and DNA sequence variations are all same, right? So of course, classically there is no inheritance of acquired characters, but there is another mechanism. Can anyone guess how could a character be inherited to, acquired character be inherited to next generation? There is another mechanism that's very popular, very popular these days. Any idea? If not genetics, then what? Classical genetics versus what? Any idea? Yeah, it's something called epigenetics. You must be aware of, right? Epigenetics is the gene expression, right? The change in the gene expression levels by various mechanisms, and most importantly, it is methylation, right? DNA methylation pattern, as well as histone modification. There are several mechanisms now available, right? So this, these epigenetic mechanisms are able to inherit, okay, able to transmit to the offspring, and there are several studies on that level. Okay, so for example, foraging behavior in chicken. That chicken with constantly changing and unpredictable food, unreliable food environment. Okay, so the environment where scarcity is very high, food scarcity is very high. Then these researchers have looked at the immune response of that. Okay, so immune response of course is changing, right? In environment with absolutely changing food supply. So resources are scarce resource, sometimes it is abundant. So immune system response is different. So they did the second generation, third generation, and fourth generation where these chicken are not subjected to a changing environment, but still they could able to see this immune system responses. So how immune system or the genes calling for immune systems are differentially expressed even after generations. Is that clear to you? So that change was first generation it was parted by differential environment, right? But that change is persisting after another generation. But the authors were able to prove that this is because of the methylation pattern that is being transmitted from generation to generation. So that is the proof of inheritance of acquired characters. Right? And there are also several of these studies. And I get another very interesting study. What these people have done, what a group of Australian researchers. Okay?